You are next.
Hi, Bianca. Do you want to do a sound check and camera check with me?
Yes, can you hear me?
I can.
Perfect.
And can the
Let me share the camera.
very good. Okay, we're set then. So basic order is I will start us off and go through the thank you to the sponsors, and then I will make you presenter. Your presentation has been uploaded into the system, and so I'll just sort of switch over, and then you can take over. How about that? That works?
Yes.
Excellent. Okay then. Well, I'll go back to being quiet and see if there's any of the other present. Actually, I see Maro's here too. Maro, okay. Let's see. Just looking to see if we've got any of the other presenters here. Well, no. So I'll check with them. I'll do the check with them before each of their sessions then. Okay then.
Okay,
Thank
so
you
you're
so
gonna share the slides and yeah. Okay.
Here, let me just bring them up and show you right now. So what I do is I go into manage presentations, and then I'm just going to be flipping over to this one. So I'll just confirm it. So I just click, and then I just basically give you presenter, and you should now have control to move them forward and back.
Perfect. Thanks.
Okay. And if there's questions, I'll be here all the time. So fair enough. Okay, I'll drop off and move the other thing back in too now. Welcome, everyone, and welcome to our second day here at on the Refereed Track at Linux Plumbers. I'm very happy to have you here. And for those who have noticed, we actually have a chat working again now. Our integrated chat is now working, so people should be able to start to use that to ask questions as people are talking, and be able to queue things up for the discussions at the end. But before we dive into our first speaker, I just want to take this chance to thank our sponsors. Our Facebook is a diamond sponsor for this year, and we very much appreciate their support to make this possible for us all. IBM is here again as our platinum sponsor, and so very much their support is definitely key, as is our gold sponsors, ARM and Microsoft. Our silver sponsors this year are Amazon, Netflix, and Red Hat. And we have Collabora basically has provided the speaker gift and supporting us in that way. And then at the end of the sessions, we will be having t-shirts for the first 200 to fill in the survey, and then fill in a subsidiary survey that basically lets them give their numbers. So the first 200 that can fill in that survey will be able to get access to a link to get a t-shirt this year. So we have a new t-shirt, and probably we need to update the slides to show the t-shirt on it. But anyhow, so yeah, there will be a t-shirt available. But that'll be at the end of the conference. And then obviously, last but definitely not least, thank you to the Linux Foundation, the Conference and Services team for supporting us in putting this on, putting this together. And one thing just to make sure is, this whole conference is working under the ALIP's anti-harassment policy, which pretty much translates to be nice and be respectful for everyone, which, given the subject of this talk, is certainly relevant. So with that, I am going to change over to our first speaker today, Bianca, and who's going to be talking about the understanding motivations, goals, and challenges faced by Linux kernel contributors. And so with that, I'm handing over the presenter wand over to Bianca, and I will drop off and let it go from there. Thanks, Bianca. Take it away.
Hello, everyone. My name is Bianca Trinkenraj, and I'm from Northern Arizona University. I'm going to talk about a survey that we are conducting, and I'm going to call you to answer that. So So who am I? I identify as a woman. I am a Brazilian. Yes, I'm from Rio de Janeiro, from Brazil. I am a mom, and my 5-year-old daughter is right here getting ready to school. I have bachelor and master's in computer science in Brazil, have 20 years in industry, and worked in many companies as an open source user. Then, in 2019, I decided to move to the US in order to have my PhD in Northern Arizona University, in a beautiful city that you can see here in the end. It's Flagstaff, with a lot of mountains and cold and snow, very different from Rio de Janeiro. For those who know Rio and know Flagstaff, the Route 66, it's quite a change. And yes, I came here to study open source and diversity, inclusion, human factors involved in, behind the decisions that people have to participate in open source. So I'm here studying with Professors Igor Steinmacher and Marco Gerosa, who are already researchers in the open source area for many years, and also collaborating with Professor Anita Sarma from the Oregon State University and Professor Daniel German, who is also a member from the Linux Foundation. And now we are working on a very interesting project to increase diversity in Linux kernel. So we are going to use evidence from the current contributors to support the strategies that we are planning to design to increase and retain a diverse set of contributors. Why that? Because we understand that the community needs to be heard. We need to listen to what the community has to say, why the contributors participate, how they perceive success, as I'm going to explain further, using the success definitions as future goals. How do contributors feel they belong to the community? What challenges, and this is very rich, what challenges do the contributors face, and what would make them leave? Because we want to understand first, this is a first step. We want to understand the current contributors. We are also going to listen to the contributors who left. And then this is going to give us an holistic understanding about how to increase diversity in the Linux kernel. So this presentation is a call to action. So if you are a Linux kernel contributor, please help us. We need to hear your voice. And please help us answering the survey until the September 2nd, because I'm going to present some preliminary results this Friday during the conference. Okay, so I have here the QR code for the survey, and I ask you to please help us to hear your voice. And this is mean anywhere in the world. So September 2nd, anywhere in the world, I'm going to close the survey. Okay, so I'm going to analyze data on September 23rd, and then I'm going to present some results to you on September 24th, right? During the diversity inclusion microconference. Well, the questionnaire is completely voluntary. There is no obligatory answers. It has mainly 3 parts, which the first one is motivation. Why do you contribute? The second one is about the contributions you are already doing to the Linux kernel. And the third part is about gender diversity in Linux. The final part is demographic, and I ask you to please don't lose this part, don't leave this part behind, because we use demographics to do some segmented analysis. So I can understand the phenomenon through different lenses. I can understand per country, what is happening, per gender, and per the other factors of demographics. So I know when you are answering in the final part, you say, oh, this is not important, but it is. It's very important for us. So please also answer the demographic. It takes approximately 10 minutes to answer, and we are not going to show your data. This is completely anonymous. The data is going to be aggregated, and we are not going to show any names. We ask for your emails and contact only if you want to be contacted for interviews, which are the next step. But none of the data is going to be used. Okay. And the first factor, okay, motivation. Motivation has been frequently studied topic in software engineering, frequently. The literature shows that a proper management of motivation and satisfaction helps the organization to achieve a higher level of productivity. So it's very important. And the largest research in open source motivations has been done around 10 to 20 years ago. Last year, we revisited the old motivation studies, and we used it. Let me see the chat. We used a new survey using the old questions to understand what shifted from the 20 years ago to today. Because the world has changed a lot, the motivations that drive open source contributors also changed, and we wanted to understand 3 shifts. So the shift of motivation that happened 20 years ago, also the shift since joining, because we can join because of one reason and stay because of another reason. So we can have different motivations since the beginning that we joined it until now that we are contributing. And we also analyzed the shift for a diverse set of contributors using the demographic. Yeah. So we found that now very relevant difference is that intrinsic motivations like fun, kinship, altruism, deeply liking, enjoying others, now are playing a very relevant role for contributors. We also saw that reputation and career can motivate more than payment for the respondents that we have. And also that social aspects are now rocking. People want to collaborate, people want to do social good. And that people can shift from extrinsic, like having been paid, to intrinsic motivations after staying there. This survey was done with many communities. Some of the respondents were from Linux, but we had also Debian, Kubernetes, LibreOffice, Firefox, and many others. Okay, and then we are going to use concept of this study on the current survey. So you are going to see a question, is the first question, about how important are those reasons for you to contribute to Linux kernel. So why do you contribute? What is more important to you? Is that hobby, like I have fun when I contribute? Is that I join it and I see career development. I contribute because I'm getting paid, I'm selling products, I want to enhance my reputation, I want to be famous, or I was asked to do a coursework, for example. Oh no, I'm motivated by the philosophy. Like I believe that source code should be open. I believe in open source, and this is my main motivation. Or also collaboration and kinship. I like to collaborate. I deeply enjoy helping others, which is a part of altruism. So we consolidated the 11 groups of motivations into only 4. So it's easier for you to answer. And we give all those examples of questions inside them, so you can mark if it's very important to you until the not important to you, each of them. Okay. And what is next? Okay, you join because of a reason. You can shift after joining because of another reason, and what do you want next? So I had a last study, my last study was about understanding success. When you understand what means success for someone, it makes a lot of reasoning about what the person wants for the future. So we asked to more than 200 contributors from several communities, what means success for them. What means success it can make a relation about what are you going to pursue for your future. So what do you think is success for you? Do you feel successful, either being or not? Think about a person you think is successful. So when you define success, you can have we have to predict what are the contributors seeking for their future, because people, consciously or not, they try to achieve those definitions of success. So we used a model, an existing model from the HR that explains success in using 4 quadrants and 2 dimensions. So we could find that the open source, all the external definitions were from open source, and the model was inside the square. So we could understand that open source contributors could understand success more from an interpersonal view, which is related to what also people think about that, but from both affect, which is the perceptions and feeling, and achievement. And how are we using this here in the survey? Well, how can we use this concept of success? A community can understand that it's necessary to create meetups, hackathons, or summer of code events for people who perceive success as collaboration, as cooperation, because they want to be together with others. People can also, the communities can also create awards for code contributors or also for non-code who help with questions for those who understand that success is recognition. So communities can create many strategies to support the perceptions of success and avoid people to have the success somewhere else. How are we using this in the survey? We are gonna ask you a question. Before, if you perceive yourself, do you think you are a successful contributor? If yes, I'm going to ask you, what makes you feel successful? I am successful because I collaborate, because I bring contributions, because I cause an impact, because I make a living, I earn money from open source, because I have fun, I like to contribute. Or if you answer that you don't feel successful, I'm going to ask you another but similar question. I would be successful if I, and then all the options. So we are seeking to have from you the definitions of success, even if you feel successful or still not. What is next? Next is sense of belonging. Do you feel you belong to the community? There are many ways of asking that and understanding this sense of belonging concept. And then we are going to ask you, how do you feel about the subsystem that you contribute to? Oh, I feel that people know me, I don't feel at home, the majority know me. So there are 6 questions about sense of belonging that with a Likert scale that you can, since the strongly agree until the strongly disagree, and you can help us to understand how do you belong, do you feel you belong to the team, okay? Then about incentives. We know that the Linux kernel and many other open source contributors have a mix of paid and voluntary contributors. So we start asking you, have you been ever in any time of your life being paid to contribute to Linux kernel? Yes or no? But when you answer yes, I'm gonna ask you, when have you been paid to contribute? Only when in the first contribution, I have been paid to in the past, but not anymore, and I'm currently being paid to contribute. And then I will ask you about your future possible decisions. If you were no longer sponsored or paid to contribute, what would you do? Would you quit? Would you leave? Would you find another employee? Would you use your spare time, your own time, as a volunteer to do what? To do new code, to maintain the code you have already produced, to help in the community efforts. So if you see, I am trying to understand your possible future decisions here regarding losing the incentives that you may possibly are receiving now. Then there are some questions about taking breaks. Have you ever taken a break from Linux contributing? Have you ever stopped contributing for 6 months, for example, and then you came back? And then what is very interesting for me to know is, why did you decide to come back? Because we want people around. We don't want to lose anyone. And what challenges did you face? And then this is open. You can write anything you want, and we are going to do qualitative analysis on that. Why? What challenges? What difficulties? What barriers in any types that you faced? This is very rich, and we really want your contribution on that. And also, do you know someone who left Linux kernel, and do you know why? What would be a reason to leave? We are going also to ask you about the current strategies that Linux have to increase diversity. So there are some programs going on, and then we are going to ask you, for each of those, are you aware that they exist? Are they effective to attract contributors? In your opinion, are they effective to retain contributors? So for each of those existing programs, we are going to ask your opinion on that, right? So we have already collected around 300 answers to the survey. And so those are some examples of the demographic we have in this moment. They are not final because I'm still collecting data. But from the demographic, we could see that most of the respondents are contributing since the 2011, so more than 10 years. They contribute less than 4 hours a week, not in the whole week. We also have data about the types of contribution, so how much of your time do you contribute to code, to community management and documentation as part of your job or being paid, and as spare time, as a volunteer. We can see that community management is being, until now, is being done more as a volunteer job than as a paid one. We also asked about when did you start contributing to Linux? No, your age. And then most of the respondents have age between 25 and 44 years old. The gender identity, and we are very interested also in the minorities. So if you identify as a woman, as a non-binary, as a non-man, please help us, because most of the respondents until now are men, so 85%, which is very attached to the reality we have in open source. So in open source, we have around 9 to 10% of women and other genders contributors, and this is a reality that we are working to change. The country of residence, we are also asking that, and please answer that, because it says a lot about the culture, so we can understand the phenomenon from many kinds of lens. Most of the respondents until now are from USA, which is expected, from then Germany, China comes in the third place, and then we are using this data also to analyze and segmented analysis. And now we come to a part of the presentation that I want to hear you. So my first question is, from those who are here, which challenges, and then you can choose to open your microphone, you can choose to write in the chat, but let's interact. I have received already a bunch of questions, but I want to hear from you. Which challenges do you face and are more impactful to you now in Linux kernel?
Bianca, in the shared note, there's a question that's been added in the sense from Asama, which is, can community support new contributors to get full-time jobs in any way, and what are the possible ways? Do you want to tackle that, or do you want to go through your questions first?
No, I can. Let me see the question again. I didn't see the question. Can you please repeat, Kate?
Sure. It's in the shared note tab on the left side.
Mm-hmm. Yes, I see.
It says, can community support new contributors to get a full-time job in any way, and what are the possible ways?
There are some options, and thank you for your question, Uzama. So I'm going to repeat once more, only for the YouTube expectations. So can community support a new contributor to be paid to get full-time job, which is like make a living from open source? If we see in the, and I thought it was very interesting that we have in the conference site some list of jobs. There are some jobs being posted for Linux contributor. So in companies that are supporting the events also. So there are jobs for a Linux contributor to work in Amazon and IBM. So you can get a job in industry in positions that are seeking for Linux contributors. So you can have this knowledge and have this job there. And the community is supporting the contributor by putting those jobs on the conference side, and also the community can make this awareness in a very like current way. The community could put the jobs offering in the page. It's an idea. Do you have any other ideas? Kate, Shua, or other contributors, do you have any other ideas? Because the partnership with industry is very strong.
And we're getting someone typing in the notes. Basically, someone Wolfram saying many companies scan the lists for new contributors. Do a reach out. So I guess in that sense, the community is engaged as well. And companies are engaging and looking for new participants when they need those types of roles. Obviously, I think there's elements of support that happens by mentoring. We heard a bit about that from Mad Dog yesterday. And so the mentoring and the community volunteers to do the mentoring, they're not being paid at this point to mentor. So I think that in that sense, the community is helping new contributors find new jobs. Well, to answer the question. We've got another question that's come in from Andrew.
Are there any companies that showed success in improving their gender diversity on their kernel team? I don't have this data yet, but makes a lot of sense to investigate, because so I don't have this data yet, but as we see that the companies are hiring for positions, the developers in Linux kernel, I think our project is also contributing to that. So the Linux kernel itself needs to be more inclusive to then help inclusivity of the companies, right? Let's see if we have any other questions, then we can go the maintain scaling.
Yeah, so what we've got is Wolfram's commenting in, my biggest challenge is maintainer scaling problem. Things like maintainers cleaning up old code and so forth.
I am still reading what is being written, but it's very connected to the challenges that I have already. I am still analyzing from the data that we have, and I'm reading the challenges, and I could see that maintainers are overloaded, and it is very, very connected to what you're saying. So the maintainer scaling problem is like the maintainers are being overloaded with a lot of work. Some of them are not being paid, not all of them, but some of them are not being paid, but even the paid ones are feeling overloaded. And we have more data about that. I'm going to talk about this on Friday. But I would ask you all, if you can, please answer the survey, because I am collecting this data, and there's a lot about the maintainers. So being overloaded and some conflicts that happen, which I'm going to present further on Friday. But like Shua was saying, the mentorship programs have help to give a good start to new developers. Yes, it's like training. So the community is contributing to have new maintainers. So, but it's like a laddering. We need to get there. The people need to be trained, and people need to be first interested. People need to be interested to be there, then being trained, then contribute, making contributions. then becoming maintainers. This is not a thing that is going to happen like this. And this is why inclusivity programs are so important, because if we don't attract new people and then we train them, how people are going to be there? So there are many, many developers in the world, and if we need to attract, we need to be inclusive and welcoming. So this is one of the challenges. Any other challenges do you want to share with us? So which challenges do you face and are more impactful, like the one about the maintainer scaling? How can we mitigate those challenges? Like Shua is showing here the mentorship programs. Any other challenges you face? Do you recommend anything? Because we are seeing Shua here answering, but do you recommend that kernel community do anything else to have more contributors who are in gender minority? Or another one, for those who are already there, what advice do you have for other contributors who are willing and trying and interested to contribute to Linux kernel? Advices for those who are already there. Do you have any advices? Would you share? For example, resilience. What else? Technical. I like the challenge about the maintainer scaling because it's very connected to what we are seeing. Do we have any more maintainers in the room who want to talk with us? Do we have people who are not contributing yet, but are interested to join?
So that's while we're sort of, waiting to see if other people sort of chime in. AJD is saying, repeating the question is, are we seeing that there are certain companies that have been effective at having success at improving the gender diversity on their kernel teams? I'd say I've seen Intel be very much. I've seen anecdotal stuff, but we don't have anything that's hard. But I've been mostly not observing on the kernel so much as in some of related projects right now. But we're seeing some companies specifically go and target to get and hire new developers and groom them up. But I don't know. We don't have actual stats right now on who specifically. But I have seen initiatives in the past from Intel, from VMware, from some of the sponsoring companies for this conference, for instance, that they would like to see these types of things improved. There's actually a lot of, the companies are trying to figure out how to do this. We don't have any data on specific to the kernel team. On Friday, there's more of some of the survey results that'll be going across companies, but we don't have any, but it's not been segmented down into the kernel side of, what's kernel specific as opposed to just the company's initiatives in general for open source work. That's an area that certainly the help for those who can fill in the survey would be welcome from this group if they've seen things. And feel free to put in comments of where that there's some good examples if you don't want to mention something here. Andre's also commenting in the chat saying, I was mentored into the kernel and now trying to help people at my university to get to kernel hacking. The hardest part to mentor people in the kernel is to find the beginner tasks. That's a good piece of input.
It is.
Yeah. I know that the ELISA project, for instance, as a group that is focused on helping people starting into contributing and trying to help with some of the cleanup of the kernel as part of learning the process. And so groups like inside a university or groups within other projects that are working with the kernel, forming groups and forming peer groups, so that people can bounce things off of each other in a peer setting, I think tends to be helpful as well. Oops. Greg is chiming in saying drivers/staging/star to do are a huge list of beginner tasks. So I think for those who are looking for them, I think that's a good one. Yeah, and Andre is saying the first patch is usually a code style cleanup, right? But there certainly is a lot of areas. So maybe, as Greg says, having more of the to-dos and making them a bit more visible sounds like something that would help.
So the next step of, sorry, Kate.
No, I'm just noticing Arnaldo's come off mute. So do you have some thoughts, Arnaldo, here?
The next steps of this, Arnaldo, go ahead. Sorry, go ahead. Arnaldo?
No, I guess it was a.
Sorry, it was a mistake. Sorry.
Oh, no problem. But you're welcome to say anything. You're pretty welcome. And the next steps of this project is continue receiving the answers that we are going to receive until the 22nd. Then we are going for interviews to deep analysis. We are also doing the segmented analysis to understand the intersectionality of the things. So what is that? For example, let me give you an example. Women cannot face a challenge, but women from a certain country can face a specific challenge, which is cultural and also related to gender. It's not only cultural, not only related to gender. So the intersectionality of the things is going to be analyzed, and then based on all those informations, we are going to start designing actions to mitigate the reported challenges, avoid contributors to leave, make the community as much we can welcoming and inclusive to other people, and see the actions, see how the actions are helping to increase the numbers, to increase diversity, and to make the community with more contributors, with diverse contributors. So it's like some steps we are doing. We are also going to interview both current contributors and also look for contributors who left, because we also need their understanding and the reasoning about why do they leave. It's such interesting to understand all the perspectives of people who are in, people who are not anymore. Let me read here the chat. We still have some minutes, right, Kate?
Yep. Going on there.
Mentored to get in the kernel, and I'm trying to help people in my university. Great, Andre. The hardest part is to find beginners texts, and this is also appearing in the challenges. So we see a lot of social issues, but we also see many technical challenges, both from maintainers and from beginners. The Linux has a complex code, and I understand it can be hard to break into small issues for a beginner to start, but it's very important, as most of the newcomers look for that tag of, like the tag of first time issue or good first issue. And when a project doesn't have this, it can be unwelcoming for newcomers. Other question, I'm not great in keeping list. Subsystem. Do anyone want to show up and ask something? Was mentored to get. Okay. Are there any? Sure, had already answered.
One of the things I'm seeing from the chat is there does seem to be the maintainers have lots of to-do lists. The challenge is some of them have it in their head, and everyone seems to have it in different places, and there's no tracking. So it's hard for people probably to serve unless they reach out to the maintainer directly to get that, and that takes maintainer bandwidth. So I'm sort of almost wondering from some of the comments we are seeing if in the chat, if there's ways that we can look at maybe these to-dos and first approaches.
Yeah, organizing documentation process and list of like responsibles is also appearing in the challenges.
Yeah.
It's related to the contribution process. It can be not, sometimes it can be not technical, it's just like process, and it causes this overload you said, Kate.
Yeah. And then I think, some of these are going to require access to hardware that people don't have too. Was the other point that was just brought up from the chat.
It's an infrastructure problem, right? To prepare the environment to contribute, which can be very challenging. Also to test. I don't know if you feel that.
Yeah. We're also getting a comment from Jonathan that's saying, first jobs are normally easy. The stuff that really takes significant mentoring is the third plus contribution. The answer isn't obvious. And Jonathan's also adding in, feel free to contribute to the QEMU emulation. It's also useful when you don't have the hardware. Okay. There's a link in also to kernelnewbies.org as well. Will's commenting, I think, encouraging a broader diversity of contributors through mentoring, beginning tasks, and company hiring initiatives is crucial. However, there's surely a need for commitment from the community to progress these new contributors so that they can grow beyond the tasks and become maintainers. For example, the list of tab election nominees are all old men with with a comment, sorry, Greg. So a desire to see more of the diversity at the tab level seems to be a factor here too, at the leadership levels.
Will, thank you for your comment. This is very attached to the advancement perceptions of success, and and then if we want to advance, we need to see like a clear criteria, right? How can we get there? Is it transparent?
Yeah, there's a really good comment from Veronica here about the challenges, in the sense that the barrier of entry is fairly high. Everyone has an email address, but 99% of the people don't have an email set up that works, because there's some rather strict rules about the emails coming into the patches. And so she was commenting last time I had to send a patch to kernel engineers and had to work for a few days at trying to figure out what the problem was. And this is after I'd already submitted some patches successfully before. So it sounds like the infrastructure is getting in the way of contributors as well.
It is, and the process, like you need to send the patches through mailing list, right?
Well, it's also, she's commenting further that, it's a turnoff for newbies to have to go and spend potentially days setting something up that should take about 5 minutes to fix.
Which gives us like a direction to the challenging that mentors have faced. Why do they have long delays of answering? Are they overloaded? What's happening, right?
Or quite frankly, they don't see it because the mail setup configuration wasn't right. So they never even saw it in the first place, which is frustrating. I agree.
It is. And possibly we can get some not complicated actions to solve those kind of problems. So it's very interesting that we can see what is hurting, because some actions can be quite simple, like communication. The person who is submitting a patch and the person who is reviewing the patch need to be able to communicate. This is infrastructure. This should be simple, right? But the infrastructure part, I know that the maintainer is overloaded, can have some delays to answer, but the infrastructure part we can fix, right?
Well, Sama just basically is responding to Greg saying he can't access the link for the driver staging.
We really need to hear your voice. So thank you for everyone who is putting the challenges here. I will ask you to please answer the survey. But I'm going to consider the challenges here too.
Yeah.
Applying to new contributors. So thank you, Jonathan.
Well,
And thank you, Edson.
and Jonathan's saying if it's just maintainers replying to new contributors, that's also a problem. And, I think one of the things I'm wondering is, how do we get those who've just been mentored and so forth to pass it forward and help, because they understand the problems firsthand better and probably are more effective mentoring. But I think building up that culture across is an interesting challenge, because the maintainers don't scale. I think we've seen that already.
Yeah.
So we need those who've been active in the kernel for a year already, being able to mentor the new people coming in and things like that. And we're still getting some good comments coming in on the typing.
Yeah, you want to spend your time doing the contribution, not figure out how to start contributing. This is very good, Veronica. Thank you. It's like possibly we are not having a proper training material set for the newcomers, and they are overloading even more the maintainers with questions and questions and questions. So
yeah, there's also from AGD, we need to see more social credit for ordinary developers to do code reviews rather than just writing patches.
Oh yeah.
So figuring out how to highlight those who are writing, doing useful code reviews and things like that.
And it's not only code review, right? It's code review, it's answering questions in mailing lists. That's a lot of work. We need to recognize all of those.
Okay.
Many people do transition to helping.
Yeah.
Mm-hmm.
It's bad enough to do that within companies, let alone on mailing lists. Yeah. Jonathan. Okay.
Do any of you have any question about the survey itself or the project itself? Like, if you see, we are trying to understand a bunch of human factors that act behind the decision. We have a decision to participate or not. We have a decision to leave or stay there. And there are a lot of concepts behind this decision. So do you have any opinion? If any of you want to complement or say something?
Well, so there's an interesting comment in the shared notes from Wolfram saying, I have a hack addition to Git, which praises reviewers and testers when I send out pull requests. I couldn't get it into mainline Git, but contact me if you're interested. So it sounds like people have been, coming up with ideas and prototypes of this type of, ways of being more visible. I know certainly the signed off buys and the tested buys and reviewed by tags are there to be used. And I think they've been counting in, the credits towards, voting for the tab and things like that. We started sort of tracking some of that a bit more last year. I don't know if she has comments there on that side of it too.
Yes, okay, thank you. We have been, I think we are also, Greg is also adding tested by tags to stable reviews, release testing as well. So we have been tracking that, and that has been helpful also to highlight some of the contributions that people make, not just the code contributions, in a lot of other ways people contribute to the community, right? Because testing is a contribution that at times doesn't get as much credit as it deserves. So that's one thing that thank you, Greg, for doing that, starting that last year, which is a great way to help people. That also starts as that is a good way to engage also, because when you test, you might find a problem. And when you find a problem, you might, that lends itself to fixing that problem. So I think all in all, smaller steps to get engaged and get involved is helpful, definitely. And then email it is a barrier. As we mentor, we notice it is a process for new developers to go through to learn how to send a patch. And that's the start, and then also explaining their patch. So some of the stuff that mentors in the mentoring process that go through, and implicit mentoring that happens, that's where the maintainer load comes in. That implicit mentoring community does in helping new developers get their patches right when they start sending. All of that does happen, but it does take a lot of bandwidth from contributors and maintainers.
Mhm. The other comments I'm seeing coming in are pointers to some of the work that various people are doing, where they're doing live code reviews in the ArchPower PC space. Daniel Axtens is being pointed out as an example that's useful. And then Will Deacon's also pointing out that Cases does this as well. And I've heard of Cases, some of Cases stuff. So, as people are doing code reviews, just turning the camera on and sharing it with people helps people understand. It's a low barrier, so maybe more of these types of initiatives might be worth considering.
And one more thing is I put a link to the live mentoring series, that webinar. That would be another good way. Contact me if you want to do something like that, talking about your subsystems, especially maintainers and contributors, expert contributors in areas. I'm looking to talk about specific subsystems so that people can learn what it takes to be an expert in a particular subsystem, and then also maintaining that subsystem. So that's probably one way to train to be a maintainer, or at least tell people what it takes to be a maintainer.
Okay, well, so I think we're at close to the 5 minutes. Did you have any further last comments, Bianca, before we sort of cue things up for our next speaker?
No, I would thank you everyone for the participation here. We had a lot of very interesting information here in the chat and also in the share note. Thank you very much for participating. I will ask again to answer the survey. I will do my best to analyze in one day, in the 23rd, and I'm going to present you some interesting results in the 23rd. So please don't lose the diversity inclusion session that we have on the 24th on Friday. Okay, then we can have discussions about the results. So we can have discussion about data there. And it's coming from you, so thank you very much.
Thanks, Bianca.
Thank you, Kate. Thank you, Shua, for the opportunity and for the collaboration. And I'm looking forward for our next steps.
Yep, I think we can keep the conversation going in the chat too.
Mm-hmm.
So I guess Bianca will be able to start typing back now there. interesting. Just found out a feature about the slides. Okay, do we have Arnaldo? Available?
Yes, I'm here. Yes,
Awesome.
I'm here.
You want to turn your camera on and just do a quick check?
Yeah, I'm testing it now.
And then I will.
Yeah, I will talk for some time, then Song Liu, which is on the screen as well, and then Namyoon, the other co-author.
Okay, so your presentation is not in a form that I can preload in. You're going to have to screen share it.
Yes,
So who's going to do the screen share? Are you going to do the screen share or Song
I
Liu?
will start screen sharing, and if possible,
Okay.
we can transition to the other guys, or I can continue passing the slides.
Okay, well then I will make you the presenter right now. And
Okay.
then you can screen share and bring up your slides and make that
Okay.
visible. And then you can, and then as the other presenters want to present and talk, they can take the presenter. You would take the presenter on the bottom with the plus sign. Okay.
Okay.
Okay, we'll get this going. So I am making
Yes, sir.
you the presenter right now.
Okay, I see the plus sign. So
Yep.
if I go here.
And hopefully you can go into screen share mode. You should have the screen share symbol at the bottom.
Yes. Manage presentation, start the poll.
No, no, you would, if further across is a screen share.
Oh,
Because your
screen share. Okay,
presentation-
I see.
Yeah,
I see.
because your, yeah. Awesome.
Yeah. Chrome and tab. So you can see the slides, yes?
Yes, we can.
Okay.
Excellent.
So,
Go back on quiet then.
and it's moving, yes?
Yep, it's moving.
Okay, great.
So if you could just wait for the top of the hour and then start then, that'll make it
Right.
easier for us when we're setting things up.
Okay.
Shall we also test the sharing screens, or Arnaldo, you're going to share for the whole session?
Yeah, I can move if there is any difficulty. Yeah, you just next, and I can move if. I think that when I finish, we can ask and she can switch for you, and then for.
Yeah, you should actually, all of you should have the ability at the bottom of your thing to see with the plus sign to say take presenter. But if not, let me just promote you right now.
At the bottom of the screen, there are 3 buttons, and now there are 4 buttons. But there is the microphone, and then there is the camera, and right at the side should have the screen share.
Yeah.
I only have 3 now.
Yeah.
Me too.
The key one here is there's at the very lower left, there's a plus sign. You all see the plus sign.
I cannot see.
No.
Yeah. Okay, just a second. Let's see. Let me go. And
Just a reminder that there's only one presenter at a time. So
Right.
right now only Arnaldo gets that. You'll have to assign presenter to the next person for them to see the plus sign or the screen share.
Okay.
Oh, no, I see it.
Yeah, I can see now.
Yep, I've made them all moderators so that they can see it.
And now I don't see it.
No. I will make Arnaldo presenter again. And then
Okay.
when it's time to change, you guys can do that.
Yeah.
Yeah. How does it work?
Yeah.
So I think you can start, huh?
Yep.
So, hello everyone. we are here, the three of us, to talk about adding features to the perf tooling, observability tools in the Linux that is hosted in the Linux kernel using BPF. As every other subsystem is using BPF, why not perf? What this is about? Perf tools is a familiar control plane to load on some words from networking where BPF is well established. You have the perf start, you have perf record, perf report, perf trace, script, perf top, perf annotate, and all the profiling tracing tools that people are familiar with for quite some time. And on the other side, we have BPF, which is a flexible, powerful data plane where we can use BPF inside the kernel to collect new metrics, to enable events when some other event take place. We can use all this flexibility of BPF in the kernel to provide new features for perf, and that's the objective of this presentation. And we also have in the BPF ecology, and we have BTF, the type information that we can use, for instance, for printing kernel data types, the ones that we see on things like strace or all sorts of other purposes. So we started this collaboration of the perf community and BPF community in the Linux kernel by enabling perf to help developing BPF. So we collaborated on having BPF profiling, where you can do a perf top, let's say, and see that there are BPF programs that are causing some specific events like cache misses or taking CPU cycles or all sorts of events that you can monitor with perf. Doing it with sampling, so you can do annotation. For instance, you can see, oh, that's the BPF program that's taking more time, and now let me see the source code for this BPF program, and let's see what is the line on this BPF program that's causing those events. And finally, for BPF event counting, how many cycles, instead of sampling, just counting the number of cycles or cache misses or any of the lots of events that you can measure with the perf infrastructure. And now, more recently, we are working on using BPF to help perf. So that, again, BPF event counting in perf these days, it will be detailed by what Sung will present. Involves, you use perf to specify what BPF program you want to count events, and then perf will use BPF to connect BPF code to the beginning of another BPF program, and then at the end, and then it will read the counters when that BPF program is going to run, and then at the end, and then aggregate this, and then present it to the user, just like it does with a normal perf event. Initially, we had this effort on having a subcommand for the BPF tool, which is the BPF canonical utility. I use a space for you to look at what are the BPF programs that are running, look at what are the BPF maps that are in place for you to do all sorts of operations with BPF, use BPF tool. And one of the operations that was introduced was for profiling using BPF tool. But this had lots of things in common with what you can do with perf stat. And so this led to using perf to count those events. And with that, I'm going to see that lots of the features that are present in perf became available to profiling BPF, counting events in BPF as well. We will be talking as well as about BPF counters, but this will be detailed by song. And we will also be talking about using the concept of BPF counters to do efficient, scalable C group event counting profiling. That's the matter of Namyoung's part of in this presentation. BPF for perf as well involves reusing a BPF infrastructure, not just using BPF programs put in place by perf for counting or etc., but things that were done for BPF to reuse it in perf as well. For instance, when a sample takes place, a CPU cycle is collected, let's say, we need to translate this to a memory map, the executable memory map where this happened, and we need to translate this into the process where that has this memory map. And the infrastructure in perf involved receiving a metadata event where there is the name of the DSO, the binary that is on some specific map, where this map is in memory, details like that. And then later on, when we would do perf report, we would have to open this file to look at the symbol table to then map to the symbol. But it could happen that while the monitoring session was taking place, an update was performed. Let's say you update the machine while you are doing the profiling for a long-running session, let's say hours. You are trying to find if something happened over the course of hours. And then when you, at the end, when you finish the session and you look at the file where the map was, it was a different file. So we couldn't resolve the symbol correctly. So in BPF, for their particular reasons, similar reasons, they introduced a helper called BPF get stack. And this BPF get stack did something that we wanted to do in perf, but didn't manage to do, which is to look at the map and figure out the ELF section where in this for this map where the build ID is, which is a unique cookie that uniquely represents that specific binary, and get it inside the kernel. So we decided to get this code that is for BPF inside the kernel, the BPF infrastructure, and reuse it in the perf record and map metadata in perf. So nowadays, when we get the notification from the kernel that the new memory map is being put in place, we get the build ID, and that is fantastic. I mean, we don't have to, at the end of the session, look for those build IDs. We remove this window of updates, and so it's one case where what was done for BPF was reused for perf, with which was really good. BPF proc profile, as I said, is limited to some events, like that's the one, the event cycles, instructions, level 1 data loads, less level cache misses, instruction TLB misses, and the data TLB misses. While perf has a lot of, vendor events, lots of events that are specific, let's say, to Skylake or to Ice Lake or to Ryzen 9 or to the Zen 2, Zen 3. There are many events. So for BPF proc profile to tapping to measure those events, you would have to go through a process similar to the one that made it possible to do it with PerfStat. And then it's a different workflow from the familiar PerfStat. So it would be really nice if we could use PerfStat for this purpose, for the same purpose that BPF profile was written. So that's you can see the help for BPF profile. You basically your BPF2 prog profile is a sub command, and then this prog, it's a BPF ID, or there are other possibilities for you to specify what BPF program you want to measure. And then there is the metric that you have to use, which are one of those 5. And this is an example of it in use. So you specify that you want to profile for the BPF program ID 324 for a duration of 3, I think it's seconds, and then cycles and ITLB meters. And then it runs for 3 seconds, and then it states the number of cycles and ITLB meters. So PerfStat for BPF. It becomes just another target. With Perf, you can specify what you want to profile or what you want to count. Let's say you can count for a PID and all its threads, or just for one specific thread, TID, or for everything that happens in some specific CPU or set of CPUs, or a C group, or many other things, and now for a BPF program as well. So the workflow is familiar, have lots of events. There are things like metrics, where instead of measuring some specific event, you measure for a metric, which involves sometimes multiple events, and those events are put into some equation, some calculations performed, and then you get that meta event, let's say. So it became a first-class PerfStat citizen. But how it works? It works using a feature called BPF scales, because there are many ways for you to use BPF, and among them you have BCC, BPF trace, and or you can do it in C. So BPF scales come to help. You just have to say what you want to run in the kernel and where, and then you can collect the information in the user space through BPF maps or etc. It all is done, and it's built the kernel part, the user space part. You link it with Perf, and then it becomes just, another event, let's say. The details are on this DevConf CZ from last year, where you can see everything that happens in tools BPF run queues lower, which is one tool that uses this concept of BPF scales. If you click on this on the presentation, you can go there. You have all the details in there. Using it, as I say, it becomes just you see the event reference cycles, and then you specify which BPF program you want. And then there is this goodie, which is not present on BPF profile, which is interval print. So every 1,000 milliseconds, 1 second, you print. And so you go on printing, and that is just like some VM stat or something like that. It's equivalent to this -B -E as well. So those are examples of Perf having new features being implemented by BPF. Now we can switch to Song, that he will talk about PerfStat with BPF backend details. Song?
So should I take over, or you gonna keep?
Yeah, I can go on moving. You just say next.
Okay, great, thanks. Hi, so now I will talk about bperf. We call it bperf. We use BPF to support the counting with PerfStat. Let's go to next slide. So here's the problem we are trying to solve. We have the data center environment, so we get so many tools that monitoring the system at different granularities. Like we have system look at tools that monitoring the system-wide metrics. We have preprocessed metrics, and some special services even care about per request cost. And on one side, the interesting part is a lot of these tools, they're monitoring the common metrics like cycles and instructions, and that's those what they care about. On the other hand, we do have limited hardware counters. For example, on Intel CPU, we have 3 fixed hardware counters and 4 programmable counters. So when there are more active events on the hardware than the hardware counters, we have to do time multiplexing. So we are facing a very tough trade-off at that time. So do we want a low accuracy, meaning we increase the interval between time multiplexing, or we get a high overhead if we reduce the interval of this time multiplexing? So I have been working on sharing these counters in the kernel for, I don't know, 2-3 years. But after quite some time, I started hating this. Is this the right way? Am I writing the correct code? This is really working. And I started doubting myself. So can we go to the next slide? So now we move to the solution is like, maybe we can use BPF to do this counting instead of like the kernel to do the management of counters. How would that work? So we only create per CPU perf event on each CPU, which means this event will not move along with your task. Then we have a BPF program trigger on context switch, and this BPF program will read this per CPU perf events, and based on the information of this context switch, this BPF program will aggregate these readings in the BPF maps. Then the user space will only read the output from the BPF maps, which is aggregated by the BPF program. So in this way, we could have multiple BPF program. We could have multiple granularity, multiple domain reading, all sharing the same per CPU perf events. Let's go to next slide. So how do we use it? So we have like 2 ways to specify I want to use BPF to do the counting. One way is to use this comma B notation that in this example, we will see like the first B, which means we want to, no, that's not comma, sorry, cycles B, that means like we want to use BPF for cycles, but with the next we have context switch without B means we do not want to use BPF for context switch. And the second example, we use -- BPF counters, which means we want that for both cycles and context switch. The result of this is like there's no time multiplexing. So in the example below, we started like 20 global counting perf states that doing both doing cycles, but with using BPF, they only use 1 counters on each CPU. And if we do the second command, which runs in parallel with the first one, it will do cycles and instructions, and they share the cycles instruction counter with the first 20 perf state, and the instruction will use another counter. So only 2 counters per CPU is used for all these 21 perf state sessions, which means we don't have to do any time multiplexing. We get the very accurate counting for the whole period of measurement. Let's go to the next slide. So here's the how this works, right? So you can see we have the blue objects, the orange ones, and the green ones. The blue ones are shared among different sessions of perf state, and the orange and green ones are 2 separate sessions. So we have the leader BPF program that is triggered on either context switch or when the user calls the leader's program. And the leader's program will first read perf event from the perf event array. And the leader program will compare this reading with a reading from a previous reading array and store the difference on a different reading array. Then when the leader program stops, it will trigger exit programs, which is the two follower program. You can imagine the FX program like a return probe or something. Basically, it's a BPF way to trigger some program when another program exits. And the follower program will check the condition of current either context switch or there's the user trigger and decide whether I want to aggregate the value in the diff reading array to my output array. And then with the user ready to read this output, the reader only read from the output array. And so it doesn't have to touch the actual reading from the perf event. So there's one condition that when the user wants to read something and the current reading on the perf event is not in the output array yet. So in that case, the user need to call the leader program. We have there's a BPF run command. This is a syscall. You can trigger that leader program on all the CPUs you need to check and use that to aggregate the latest reading from the perf event into the output array. Then the user space read output array, which will have all the information, all the contents we have. So let's move to the next slide. So there's something tricky. It's like we want to share these perf hardware counters among different processes. So we achieve this by using a BPF map, and we pinned that in this location. We call it a perf attribute map. So basically, the map have data like the one below. It has a link ID, which is the BPF link of the leader program, and the diff reading map ID. So when a user wants to share this perf event, it will hold a reference to the link ID. And because the link ID, the BPF link hold a reference to the BPF program that hold a reference to all the maps we use. By holding a FD to the link, the user will hold a reference for everything. And when all the users exit or we close all these FDs, the perf event, the program, and the map are freed. So we won't be leaking any resource, but we still get the sharing going. So next slide, please. So with this approach, we could have like this all monitoring daemons and all the services that are doing self-monitoring for the same metric in reading the ping the BPF map and using the same protocol to access these perf events. So right now, the kernel supports up to 38 follow program per leader program, which means I think we have more than enough sharing for the system from all the use cases I've seen. I think that's all I have. With the next slide, yeah.
Okay, thank you, so. My name is Namyeon Kim. I work for Google at Linux kernel performance instrumentation team. So I'm going to share how we use BPF to use perf event in a scalable way. Next, please. So our use case is that the Google data center runs lots of jobs in the machine. So we want to monitor those jobs running in a C group. So we want to monitor C groups using perf stat. So a few of my colleagues already talked about this topic 2 years ago at LPC, so you can refer those talk to for more details. Next slide, please. So during that we faced scalability issues so each C group, to monitor the C groups, each C group has its own perf event. That means we need a number of events multiplied by the number of CPUs multiplied by the number of C groups. So we need that many file descriptors, and it also has memory pressures for the backing storage in the kernel. And also it increased the overhead during the context switch when the C group switch is involved in that. As each C group has its own set of events, when it's switching to a new C group, you need to program the hardware PMU counters each time. So that adds many overhead in the critical path. So we used a workaround that first we need limits the number of C groups to profile at once. So and it makes some blind spots, and we cannot see the consistent data across all the C groups since we have some fresh metrics for some C groups, but others have stale data. So that's the problem. So next, please. So looking at the C group perf events, they are basically a kind of CPU events, but they are associated to the single C group. And we are using them as we want to monitor lots of C groups, but essentially they are using the same set of events. This is the common use case at Google, and we use that. We use the for C group command line to ensure we can remeasure the same set of events. But actually, there's no need to have separate events for the C groups since they are basically CPU events. So we can share a single CPU events for C groups. All we need is just a separate count per C group to aggregate the events for its C groups. So next slide, please. So I proposed in-kernel aggregation approach using the I/O control interface. So I proposed two set of interface, one for adding C group counters for the existing CPU events, and one to read the C group counters from the event. So basically, it does similar things. On context switch, it reads the current perf event counters and aggregates it to current C group. So in this way, there's no PM reprogramming is needed during the context switch. But it was rejected by the perf kernel maintainers due to some interface concerns. And so next slide, please. So I came up with the BPF approach, and during the time the BPerf infrastructure was added, so I can share that infrastructure to do the things but it's a little bit different use case in that for original BPerf, want to share perf events across different processes. But in this case, I just want to share perf events in a process, but across different C groups. So I made some modifications that I added to kernel 5.13, a software event called C group switch event. It's similar to a context switch, but it only triggered by context switch involved in different C groups. So we can save some context switch overhead during that, which if the task got switched to a same C group. And in this case, I don't need the leader and follower separation. So I just use single BPF program to the counting and aggregation. And so it collects the events and saves the result in a percipio array and C group ID as a key. So next slide, please. So actually, we are experimenting with this and want to deploy it, the BPF perf step after some experiment. So I can share some benchmark result, estimate the context switch overhead. In this benchmark, I use many tasks communicate with the pipes, but each task is in a different C groups. So this graph shows that the blue line is the baseline, this context switch overhead without perf running. And red line is the existing perf step with C group events, the way we use right now. Then the green line shows that the BPF approach. You can see it's much closer than the baseline, the blue line here. So I think with this approach, I can make it more scalable, and actually it can get rid of the file descriptor and memory pressure due to the many perf events, and it can save the context switch overhead. So I expect we have more scalable perf monitoring with this batch. So yeah, that's it. I pass it to Leonardo again.
Yeah, so we saw three approaches of implementing new perf features that at first were attempted to be implemented on the usual way, without using BPF, trying to add functionality to the kernel that would then be activated by perf, and then by the perf tooling as a space. But and this was attempted multiple times. I mean, so it was interesting to me to see when Namjoon decided to try the BPF approach, that he stumbled on some difficulty. There was something that was not working, was missing, and Peter Zilstra, the kernel maintainer for perf, he, instead of complaining about this being done with BPF, he was, I mean, disappointed that it couldn't be done with BPF. So, I mean, it was a stamp of approval that made me really happy that someone who understands all the details, or more than me and more than anybody else, I think, thought that using this approach was valid. It was less complex, was more flexible, and that we should continue pursuing on this path, which we did, and it resulted in results as you could see from that new graph. For the future, there are other ideas that we have on using BPF to implement new perf features. One of them is this triggers, which is you set up some events, some perf events, be it K probes or U probes or some BPF events or any event, and but you don't want to measure it all the time because it will produce lots of data. You want to produce to count those events or to sample those events only when some other event take place. So only when you start swapping, you want to see what's happening. Only when processing a transaction takes more than what's acceptable, you want to enable those things. And then when things get back to normal, which is another event, you stop measuring. So you, inside the kernel, can limit what is being sampled or counted or whatever. So that's something that I started working on these, and I plan to resume soon. There are other things from BPF, like BPF get branch snapshot that Songli has been working. I think he can talk a little bit about it, just briefly.
Yeah, sure. So this is what we have been working recently, is to use the branch snapshot or branch recording hardware, or we call it's called LBR on Intel CPUs, and with that slightly different name for other architecture. But basically, right now we have that it's very useful on a hardware event on sampling what's going on with all these branches in the system. But we found that could be also super useful on a software event. Basically, for example, if you have a long syscall say perf event open, and you get an error, but you don't know why is returning this error. Is return your inval, it's invalid output, but exactly what's wrong with that. So this on the software events that will trigger this and get a branch trace at that point. And by looking at those branch, you will see, okay, this is perf event open function at this offset. We say go to error out. That means, oh, okay, something was wrong. And that piece of information is very useful in debugging such issues. Otherwise, we imagine you're gonna keep adding print k to your perf event open, or keep changing your perf event open argument to try to figure out what's going on. So right now we have that on the BPF side. So on the BPF software event, you can call this helper and dump the branch records for you, and then you can start making sense by looking at the WARF information on your kernel binary.
Yeah, so I think that this is what we had to say, and then I think that there is 5 minutes for questions. Does anybody have any questions? I'm looking at the chat. I'm not seeing any question there. Just
Oh, I'll just join in for a minute to, are there some specific areas where you're looking for help with?
For help, I mean,
Mhm.
the testing is an area where, I mean, for perf specifically, and for all those new features that have
Mhm.
perf and BPF in together, it's interesting for testing because I mean, we have perf test, which is a subcommand perf test. You can, if I have perf installed, you can run perf test, and then you run lots of tests that test for various aspects, including the BPF integration. But more are welcome.
Right.
So that's one area. You to contribute with that, you don't have to know, let's say, C. You could, there are shell tests where you run, you create a shell script, a bash script, and then you specify, run this command, get the output, check if the output is what I expect it to be. Let's say you ask for a backtrace, and then the backtrace comes. You know that the backtrace should be main calling this other function, and then if it's different than that, it's a problem. You should flag it. There are some examples of such tests that does involve C programming, but if you are versed in C, you can as well add C-based tests or any other language. The number of features that are present in perf and in BPF, and when you combine both, it's quite a lot. So having more and more tests for that is really important. And in developing those features, I mean, there's always space for more people interested in learning and participating in the perf development and BPF development.
Well, do we have anyone else that's around that would like to turn on the camera and ask questions about this content? Okay. Is there anything that's showing up in the chat? Just double check that. Still takes a while to switch back and forth between the chat and the screen share for me, I'm afraid.
Yeah, I mean, there's a question about if I consider writing a book on the perf tool. Yeah, I considered writing a book, and even there was a conference in BPF plus networking in Puerto Rico, and I've met Brandon Gregg for the first time, and he was the one who was encouraging me to write such a book. But writing a book is a big endeavor. I keep thinking about it, and I have a really young kid now, and it's taking a lot of time. So I may end up doing that, but I don't think it's something I'll be doing in the near future.
Okay. I'm not seeing any other questions come in. It was an excellent presentation. Thank you all very much for pulling it together. It was much appreciated. And I assume you'll just sort of hang out in the chat if other questions sort of come up for now.
Right, sure. Thanks a lot, everybody.
Thank you.
Thank you.
Okay. Take the presenter back. Yeah. Hi, Vlastimil, are you here now? Let's do a sound and camera check.
Hi.
Hey, okay, I can hear you. This is a good start. And I've given you I've given you the access to the presenter. I see you
Thanks.
found the cursor. So can you move the slides forward and back? Are we good there?
Try. Yeah.
Okay, then. And I'm going to drop off. And if you want to start at the top of the hour,
Okay.
that. And you can, turn your camera off, or you can leave it on, whichever you're more comfortable with. For this. It'd be good if while you're recording, and if you could remind people that if they want to ask questions, if they want to just turn their camera on, or they can use the chat or the shared notes, whichever is most convenient, or whichever you prefer to look at. Okay, I'll try to keep an eye on them as well and help with anything that's sort of coming up from there and factor it into. If you've got any
Yes.
questions.
Switching between shared notes and chat takes some time. So
Yeah, that's why. I'll tell
If-
you what, if you want to stay in the chat, I'll go and keep an eye on the shared notes. How about that? And then let you know if there's anything that shows up there.
okay.
Okay. Because the chat tends to be a bit more active now. So.
Is the red dot visible?
Mhm.
Okay.
And I guess we're at the top of the hour, so last minute,
Yeah.
welcome, and feel free to get started when you're comfortable, and let people know how you want them to engage.
Okay, thank you. Hi, welcome everybody. I'm Vlastimil Babka from SUSE Labs. I'm working on memory management for 8 years now. And although memory reclaim wasn't my expertise, I focused on compaction, which I talked about Plumbers in Vancouver 3 years ago, and I now also focus on slab allocators. Just last year, I had to really deep dive into the topic of reclaim, so I was able to solve some issues. And I thought since I had to learn all this, I would try to explain it to others as well. So I did that first last year at our internal conference, and this year I'm presenting this here with some fixed bugs and updated content. If you want to ask some questions during the talk, it's fine. You can turn on your webcam and unmute yourself, or use the chat or shared notes. So what is memory reclaim about? So in Linux kernel, the philosophy about memory is that unused memory is wasted memory. So everything that the user space programs touch or read files from disk or map them will stay cached in the system RAM. So that means unless the system is really idle and the RAM is large, eventually it will get almost full, and then memory reclaim is there to evict some of the pages and the data there to make room for any new data that user space wants to use now. And at the beginning, the main distinction is that user space actually uses two kind of pages. One are allocated on demand by mmap and with the private flag and anonymous flag, and are not connected to any files on disk. And yeah, they are populated by the user space writing some data to there. Otherwise, they can be just backed by a shared zero page. And if we want to reclaim this kind of memory or pages from RAM, we have to put them to swap partitions or files. Otherwise, they are not possible to reclaim at all. The file pages are brought to the RAM by either running some buffered IO operations or mapping file, and again accessing the mapped pages. And this is also known as the page cache. And the difference from the anonymous pages is that any writes to the mapped pages have to be flushed back to the files, but then the clean pages that are not written to can be just discarded because there are still the files on the file system that are backing them, so they can be brought back when needed. So that's a difference between the anonymous and file pages. And yeah, so at some point we will fill the memory, and we would like to keep only the pages that will be accessed again soon, so that we don't have to spend disk IO to bring the pages back to RAM, which is a hard problem because we cannot, of course, predict what the program will do in the future. So what we can do instead is look at the recent past and assume that the pages that were accessed recently will be accessed again in the near future. And the canonical way to do this is to put to sort of logically order the pages in the so-called least recently used order, which in terms of kernel structures means that the struct pages that are describing the 4 kilobyte pages with data will be linked with the linked list head in the kernel in such least recently used list. So the pages accessed last will be, or the most recently will be at the head of the list, and the old pages at the tail of the list. So that would be the ideal model. So let's say we have pages just numbered 1 to 10 that are ordered in this way, and we access, or the user space accesses page number 5, and in this ideal LRU, that means the page number 5 would be brought to the head of the list, and pages 1 to 4 would be shuffled a bit back, and from page number 6 the list stays the same. Now let's say user space accesses page number 11, and we have only room for 10 pages. That means the page number 11 will be brought to the head of the list, and the page number 10, which was at the tail and doesn't fit anymore, will be reclaimed, or also called evicted. Now that would be the basic model, but in practice this is of course very different. As I said, we have different properties between the anonymous and page cache pages, which makes their reclaim like have a different cost in terms of IO, disk IO usually, because we have to swap out anonymous pages, but clean pages can be just thrown out. So historically, reclaim has always been biased somehow towards reclaiming file pages more than the anonymous one. We could still track them on the same LRU list, but if we want to handle them differently, it makes sense to also have separate LRU lists for each type. So in fact, we have just that. So we can decide independently, are we now reclaiming file pages or anonymous pages, and we can process the list that contains just these kind of pages and don't have to skip the other type. So instead of common list with both file and anonymous pages, we have a separate list. But since we wanted to have the control, we now actually have to perform this control. So we have to choose which one would be reclaimed and how we want their sizes to eventually converge to. Another complication or more complexity is that we cannot just use the ideal LRU model as I was showing, because that would mean we would have to capture each access to a memory page, so we could bump it to the head of the list, which would of course be prohibitively slow. Ideally, the kernel isn't concerned with most of user space pages, because the CPU handles the page table walks, or there are TLB caches, and the kernel really doesn't have that much insight, real-time feed of what kind of pages are accessed, because it would be really very slow. So we have to track them with a lower granularity than on each access. So what we do is that sometimes we check which pages have been accessed since the last check, and that is more effective if we can assume that some pages are really actively in use, and it would be pointless to keep checking them, and some pages are not as actively used by user space, so these are those that we should check more often and reclaim those that are not accessed again. So for this, the LRU lists are further split between active and inactive LRU lists, and then there's also a fifth one, which is for unevictable pages, which are not really reclaimed, but the code is simpler if it can assume that every page is on some kind of LRU list. So that's why there's a specialist for them as well. And this question.
Yes, one question. So from my understanding, one of the reason for splitting into inactive and active was particularly the workloads, the streaming workloads, which access the page once, and therefore we want to keep it selected.
Yes, that could be achieved even with a single list, but it would be really not effective, because even on the inactive list, as I will show soon, we further distinguish these kind of streaming workloads and those that are not.
So here, you're the one reason you mentioned, we more effectively track more or less actively pages separately. So we don't really, the kernel currently does not really it is more about it is reclaiming from the inactive, but it's not really monitor or track the active list more actively, right?
Yes, that's also, I will get to this exact process. So yeah, and because we put those active pages on a separate list and don't monitor them closely, it saves the time to look more closely on the inactive list. So there's somebody raising hand.
Yes. How do you define fairness between these LRU in terms of capacity? Because if you give set the capacity bigger for one LRU, it may not be fair for another LRU.
Yeah. I will get to this.
Okay, thank you.
So yeah, the last thing is that this terminology is that this group of 5 list is called an LRU vec, which is a vector of LRU lists. But the splitting doesn't actually end here, because to these 5 lists, because we also have I will get to how. So we have 4 lists logically that can be reclaimed, and then we move pages from the inactive to active, which is called activation, or vice versa, which is deactivation, or we can during the reclaim just keep them on the same list, or evict them, which means we have reclaimed them and can reuse the page for something else. But in practice, there is not a single LRU vec, but many of them, because these days we have memory C groups, and sometimes we are not reclaiming the whole system set of pages, but just from one memory C group. So the various limits are followed. And then we would want to iterate from pages from just a single C group. So that's of course more effective if there are lists that contain just pages from a single C group. Then we also distinguish NUMA nodes because they can have different sizes and speeds, and the processes can be using mem policies to limit their usage on each NUMA node, and that means there can be different kind of pressure for free pages on each NUMA node. So that also makes sense to reclaim each one separately, or run a kswapd daemon on each node separately, so it works with local pages, which is more efficient than remote. So it means it's again more efficient to have a separate LRU list for each node. So in the summary, the number of the LRU vecs comes as a product of the number of nodes and number of memory C groups plus the root memory C group. Now, what exactly how exactly reclaim tracks the pages on the LRU lists? So we have various page flags dedicated to reclaim. So one flag is called LRU, that means the pages on some LRU list, and the MM subsystem knows that it should treat them as such. Active flag denotes pages then that are on the active list. So it's easy to find out, and we don't have to scan the list. Referenced means an inactive page that had been accessed recently. How exactly that's used, I will show you soon. And we'll also get to what the working set means. Like logically, it means we think the page is actively used now by the user space, but what exactly it means we'll get soon. Now, how the reclaim finds out which pages are being accessed, so it can, for example, activate them or not reclaim them. So on modern CPUs, we have this situation made a bit simplified, because the CPU helps us, and if there's an access from user space process, it will enable an accessed bit in the page tables, in the page table of the process that maps this page. But once we are processing the struct pages on the LRU lists, we have to somehow get from the struct pages to the page table entries of the processes that map the page and look at these access bits. For that, there's a function called page reference, which does something called an RMAP walk, which when RMAP is a data structure that allows us to get from the struct page to the processes that map it and these page tables. And this function counts the accessed bits and also resets them to 0. So from this moment of check, we can wait if there will be further accesses by the user space that would set the access bit back to 1, and we can find out in the next check if we could access it. So we have this struct page that has these page flags related to reclaim, and that through the RMAP structures is linked to all the page table entries of the processes that all map the same page. And we look at the accessed bit in these page table entries. This layout is from the x86. And if there were four page table entries and one of them would have accessed bit set, then this function would return 1 and also reset this bit back to 0. And now how all that is used. I will now show you a kind of state diagram for each page that's considered by reclaim. So initially, for example, we map some file from the disk, but the user space process doesn't touch the page yet, so it's on the disk and not present in the memory. So that can be our initial state. And now there will be some initial page fault, which will read the page from the file and disk and put it in RAM and map it to the page tables of the process, so it can resume the page resume after the page fault and really work with the data. And after the fault is handled, there will be a page table, single page table entry that will have the access bit, and this active and reference bit for the page will be initially 0 or false. And the green arrow mean that this transition was done by either a kernel access or a user space access. So in this case, that was a user space access to the page fault. Now, let's say there's a reclaim round process, because this page is not active, it's on the inactive LRU list, and eventually it would get to the back of the, if there's no further access, it will get to the tail of the LRU list, and the reclaim will look at this page and it sees there's one page table entry that was accessed, but that's not enough to immediately put the page on the active list, because as Shakil pointed out, that wouldn't distinguish this kind of streaming workloads that just access each page once. So after the first access, we just turn this accessed bit into a page referenced flag on the struct page, and the access bit is of course reset to 0. But the page is kept on the inactive list, and it should really prove itself as being used more than just once to be really considered active. So, and this orange arrow means that reclaim keeps the page on the same list, the inactive one, but it can change the flags, for example. Yeah, so now let's assume that the page is active, so the user space accesses some bytes from the page again, and again the CPU will activate the page table entry. It will set the access bit to 1, but here I say it's above 0 because at this point we don't distinguish if it's 1 or more. And the page also still has the reference bit. So yeah, the user space page just again sets the active bit in the page table to 1. Now let's say the reclaim again processes the inactive list and now sees this page and sees that it has referenced flag already set, and again there was the user space access, there's the access bit or more of them if it's mapped to multiple processes. So now the page is considered active and it's put on the active list. So that means the active page flag is set to true. And at this point, we actually don't care about the referenced flag anymore. But the page is activated and the blue arrow means that there's a promotion or activation to the active list. In the other case, if the page on the inactive list with the referenced flag set to true was not accessed by user space, but processed again by reclaim on the inactive list, it would be reclaimed because there was no further access by user space or kernel, and it means it was probably one of those streaming workload pages that was just accessed once, and there's no point in keeping it in memory. Now, sometimes, not always, the active list is also processed, and the reclaim on active list means that if there are no further accesses, so the number of accessed bits is 0, the page will be deactivated and put back to the inactive list. And the difference between this and this is that there are still no accessed bits in the page table entries. Yeah, but if there's another user space access, it again means that there are some accessed bits and the page can go again through this process. But if user space really doesn't access the page anymore, another reclaim on the inactive list will see no accessed bits and just reclaim the page. But if the page was on the active list and further accessed, it would again increase or set some of the access bits to 1 in the page tables, which is distinguished during reclaim of the active list, but only for executable file pages, which are those that hold the code of the program or shared library. And these are kind of preferred by the reclaim to stay in the memory if they look really active. So the reclaim of the active list will, only for these executable pages, it will not put them back on the inactive list, but will just remove the access bit and keeps them on the active list. So if they are really, the code is being executed, it will stay active. Yeah, but if it's not executable page, then even the accessed bits don't matter anymore on the active list, and reclaim would deactivate such a page. Another situation where the executable file pages are sort of getting preferential treatment is that if they are on the inactive list and but have the page table accessed bits, they are also immediately activated and then don't go through this referenced path first. Another situation that's distinguished is that if there are multiple processes accessing a page on the inactive list, that means the number of the page table entries with access bit will be more than one. Then these pages will also be promoted immediately to the active list and not through the referenced path first. So that was accesses by user space touching the memory and the CPU setting the access bit in the page tables, but we also monitor like accesses from the kernel, which means there can be a get user pages operation in the kernel, which can be done by some drivers, or these kind of accesses can happen through a buffered IO read. And so for these, we cannot rely on the page table entries and their access bit, but we can handle these kinds of operations similarly. So if there's such an operation on inactive page, it's treated as referenced, and if it's referenced, it's promoted to the active list, similarly to the user space fault. So for completeness, these transitions exist as well for the kernel accesses, and yeah, here we don't distinguish that there might be multiple page table entries as well. So that's the basic state transition diagram. And now another somewhat recent improvement to Reclaim is called working set detection, which helps in balancing the sizes of the inactive and active list and file and anonymous lists. So what this tries to do is that that if the workloads were kind of stable and steady state, we could somehow achieve the on core verge on the pages in memory being the active working set. But sometimes the working set will transition, so the user space will access one set of files, and now it will start accessing a different set of files. And we would like to distinguish this change and quickly reclaim the old pages and bring in the new pages. But with the scheme that I was showing, by proving the pages on the inactive list with the reference flag, this might not be sometimes sufficient, because the inactive list could be too small and we would just be trashing the new pages. So this mechanism tries to detect this situation, and there's some mathematics behind it. So it tries to approximate the distance between two accesses to the same pages, which is called access distance. And that means, for example, if it's 5, that means 4 different pages were accessed between accesses the same page. So it's like in this example, 7, 8, 9, 10, 11, and 7 again. That means the distance between the two accesses to 7 is 5. And for example, if the inactive list has only 4 pages, then each of these accesses would be a fault because they would just not fit. And we would always think that the 7 is a new page of a streaming workload, and we wouldn't recognize it's in fact a new working set. So what this tries to do is to remember the access distance even for pages that were evicted. So at some point we evict the page 7, but we remember its access distance, and on the next access we can find out, oh, if the inactive list was just a bit larger, it would fit. This is the basic idea behind working set detection. So there's this explanation on how this is calculated, which I guess I will not go through in detail because spent much time, and but you can read it up from the slides later. But the main thing is that we, as I said, we can track the access distance for each page that we evicted, and then compare it to the size of active list. And if it's smaller, it means that if the active list was smaller and the inactive list larger, then this page would actually be able to stay in memory and not trash. So if this inequality holds, when we refold the page, we activate it immediately. So in this kind of diagram that I've shown, what the working set refold does is that for these pages where we detect there are refolds based on these calculations, we can go directly from the not present in memory to the active list. And that means the page has a high chance of staying, and the old active pages that are not accessed by the workload anymore will be eventually reclaimed, and there will be no trashing of these new pages. So initially this was implemented only for file pages based on those calculations. So how it's implemented, for each every time we evict a page or activate a page, we increment a counter associated with the LRUVEC that's called non-resident age. And then we track the refold distance by remembering the value for the page at the time it was evicted, and a value of this counter at the time where it's refolded, and the difference, or how much the counter has grown between these points of time, is the refold distance. And then we compare it, the refold distance, to what we to the sizes of all the other lists, or LRU lists, besides the inactive list, which is not intuitive anymore, because now, but there is, it doesn't feel intuitive while we are comparing this to the size of active file and anonymous and inactive anonymous page. But what it effectively really does is it compares, it does the balancing between the anonymous and file pages, and also between the active and inactive lists, and to some extent it works. but it's not really intuitive to explain it anymore. And of course, the anonymous lists are only considered if swap is available, because otherwise we cannot swap the anonymous pages out. So there's no point in comparing any distance with these pages. And another thing from the working set detection is that when page was active and is deactivated, we set the working set flag, which is also recorded even for pages that are then reclaimed. And if they are then refaulted back, we restore this flag, and that plays a role a bit later as well. So how then does the reclaim work for the non-memcg case? So eventually, if we reclaim from casewebd or direct reclaim, we go through a shrink node function, and then we have to decide if we will be processing the file pages or anonymous pages. And now there's a formula that tries to set the ideal ratio between active and inactive based on the amount of memory in the system. And if this formula says that the inactive list is too small, we are allowed to reclaim or process also the active list. Otherwise, we are processing just the inactive list. Then we have to decide if we reclaim the anonymous or file pages. So there are some corner case decisions that try to actually prevent some corner cases, like having too small file list or too small anonymous list. But yeah, and so based on these heuristics, we decide if we reclaim one, both, or two, one of them or both. And then we actually try to calculate how much to scan from each of the 4 LRU lists. And this is done using so-called fractional cost model, which again is some bit of mathematics that combines the sysctl called VM swappiness and also the refaults that have the working set flags that I was mentioning before. That means there was an active page reclaim, and we should avoid them. So basically, if there are more active page reclaims on the file list, we focus more on the anonymous list, and vice versa. And this is also weighted by the swappiness, so the user can also have an influence in this. And this is how it tries to balance these 2 lists together. And then we just go through all the LRU lists, either inactive or also active, based on if we are allowed to process the active ones as well, and consider each page according to the state diagram I was showing earlier. And then there are again some specific details about when we terminate and how much exactly is scanned and reclaimed in the end, but these are just details. Another thing that can influence reclaim and is related to this is some of the advice syscalls. So it might be also useful to know them, because initially we had just the don't need that just throwed away pages and including their content, and but these days we have 3 more. So for example, Medvice free is only for private anonymous pages, which will also throw away any content that's already not on the disk. And it will put, what's interesting is that for these anonymous pages, it will actually put them on the file inactive list, which means it's assuming it will be discarded sooner than if they were on the anonymous list. And these very new ones, Cold and Reclaim, are different in the way that they are not destructive. So if there are dirty pages, they will be swapped out or written back to the files. So how Medvice code works is that moves the page to inactive list, but of the corresponding type, not the file list. That means it will be reclaimed sooner. And Medvice reclaim actually immediately reclaims the pages in a non-destructive ways. So if you know how these lists work, you can now have more insight of what these Medvice modes do. So the conclusion to what I was describing is that even though it was lots of details, it was still kind of high-level overview, because there are still more special cases and details, and I have omitted lots of them. For example, MCG specific reclaim, SLAP reclaim, the interaction with compaction, and so on. So the point is that this is overall really complex systems that's resulted of years of evolution, and including big recent changes, the working set ones, and there's no overall documentation, and that's one thing I would like to improve, although I have procrastinated on it for a while now. And what's the main problem with this, that as you can see, it's quite complex, and now if somebody proposes a patch that's supposed to improve it, it's really hard to predict what it will do in the overall picture. So it may improve some workload for the submitter, or but it's hard to say what it will do for other workloads. Will they also improve, or will they regress? So will they have worse performance, or even some corner case of really bad trashing? And yeah, the question is really how to get some better insight, whether we should simulate what's really happening with the lists, or use tracing, or so on. Mike asked if we discussed the docs in 2018. Yeah, I think that was for the compaction talk, and I also didn't create the docs for the compaction. So yeah, I have some work to do. Yeah, if I can spend a few more minutes, I know it's late. I also wanted to say something about recent series that were related to Reclaim. So one is that we can migrate page to slower memory, for example, persistent memory or for the NOMA node, and instead of like throwing it away completely. And this was actually just merged for 5.15, but there are some more work to do. And since I noticed that the memory tiering is on the agenda for the performance and scalability file system in 2 days. I will just leave it to the author to talk about it. And so I will mention instead this multi-generational RRU framework, which was submitted this year. And yeah, and I think it's really example of here we are proposing a big major change, and now it's really hard to decide what to do about it. And it is hard even for incremental changes, and this one is even more major. So instead of the 2 lists, I was the active and inactive, it can have multiple lists, at least 3 or even more. And within these so-called generations, it also further distinguishes tiers, which are different tiers than the tiered framework on the previous slide. And so that's one big change. And another big change is that most of the scanning to get to the accessed bits, it's not done through the RMAP walk by walking the LRU list, but scanning through the page tables directly, which is many advantages, but also doesn't work well on processes where the page tables are too sparse, so it will fall back on the LRU list, which is good. And actually it was, as I learned, even done this way in 2.4 days of Linux before we switched to the LRU list. And the reclaim and the balancing is done really differently than what I described is done today. And there's also more knobs in sysfs for user space, so it can influence this, which can be good or in some scenarios. So the point is that it really seems to reduce CPU overhead and latency, and some people said it allows them to avoid trashing with multiple tabs in browser, even on low memory systems, which is great. But yeah, the problem as I see and other MM developers is that it tries to change many things at once, and we really can work well with incremental improvements. So what I could, for example, imagine is that the page table scanning would be tried separately together with the existing mechanisms, because it really seems it can be useful. I can imagine these days we scan page tables also in KUge PageD to collapse huge pages, or in NUMA balancing to do this kind of stuff. So maybe this could all be unified, and there would be a single scanner of page tables that would do also the reclaim, and that could be really more efficient than having 3 separate of them. But yeah, I think this would be better discussed at LSF MM or something that's currently not, unfortunately, not happening this year. So with that, I'm sorry for taking too much time, and that's all from me. Thanks. If there are any questions, I don't know if we can still answer or move it to the chat.
Probably best to move to the chat right now, since I think we need to let we need to let our next speaker see everything up and so forth. But thank you very much for a very informative talk. And at least, even though it's not documented as much as we'd like, we have this video now to refer to for people who are trying to understand this. So thank you for doing such a nice comprehensive work.
Thank you.
Okay. And Feng Teng, are you on? Do you want to unmute?
Okay, yeah, yes, I'm on, yeah.
Excellent. Okay, I will put your key for you to make sure I can make you presenter. And then if you could start at, there we are, I see you now. If you want to check that your camera's working, that'd be great.
Yeah, okay. Okay.
Yep.
So shall I start now?
I'd say give it 3 or 4, start at the top of the hour. That'll make it easier for us when we're editing these. And do you want to just check that you can go back and forth?
Okay, yeah, okay.
While we're waiting?
Let me try to, okay. Yeah, that works, yeah.
Okay, good.
Okay,
And I'm
thank
going
you.
to go. I'm going to turn off my camera. But if you could turn your camera on when you're ready to start, or you can stay on. It's fine. But just if you could start at the top of the hour, that'd be good.
Okay, sure. I was.
Hello everyone, I'm Feng Tang. I'm from Intel Linux kernel team, and today I'd like to talk about some strange kernel performance changes we've seen recently. So some background here is that we have the zero-day team, which is a contest report robot. It keeps testing the kernel performance and reporting the regressions and improvements. And recently, actually, it's about 10 years ago, we start to see some strange cases, which are hard to explain because bisect commits seem to have nothing to do with the benchmark, like something change in the memory management can affect the benchmark in the scheduler. So, so the kernel developers, which is bugged, include Linux, suspect it is the result, and sometimes they will challenge the report because it doesn't make any sense. So we have put quite some efforts to try to understand, explain them, and also we try to mitigate them. Because our work, many of our work are actually some hypotheses, and so we are so any ideas or suggestions are highly appreciated and welcome. Okay. Okay. Here we'll go through about the kernel layout of the different sections. We have the text, read-only data, and the CPU data, and other sections. This is from we get from the system map. According to the cases we checked, which is about more than 20s, the red sections are likely to happen. Most of them are commits are related to the text, data, and the CPU data sections. And for others, it's green. It's just fine. Oh, sorry. So the inside the kernel, all the sections are actually linked very compactly. For the text, yeah, they just be close to each other. And for data, they're similar, but here we leave some gaps because in the data we actually in many places we intentionally put some alignment there, so there will be some natural gap between different modulars. Here the A, B, C, D means different .o files. And also the link orders is important here. So here I just list some of the orders based on the Makefile. So the kernel, so this is will be the null address from illicit, then the arc code, then the kernel memory management, file systems stuff, and the drivers and network is at the last. So in short here, I list the order here because if there's some change in the illicit section in this block, we can see it will affect all the blockers followed. And if you have some change in the drivers, it's just affect just a few. So according to our debugs and tests, we found that most of these strange clock performances are caused by the alignment, the catch alignment changes. The patch, the elements including the three categories. The first is the text, the function alignment, then the data alignment. And what matters here in the data alignment is mostly about the force sharing. And also we have some we saw some cases related with the hardware catch prefetchers. For this one, this is transparent to the software programs, but sometimes it has a huge effect on the performance. One thing I need to note here is that for those strange cases, mostly they are from benchmarks of some micro benchmarks, like the weight scale, the VM scalability, the hack bench, the lead perf. So seems that those benchmarks can amplify this effect of the catch alignment changes. For the hardware prefetchers, there are several types, but the most important are these two. One is the adjusted catch line prefetch, and the other is the L2 catch prefetcher. And I will give some more details for this. For the text, first I will talk about the text alignment. The clock functions are all linked together compactly, just like this right block. You can see that they're too tight packed. So one line change of code can cause changes to the whole kernel following it. And the earlier the dot all get linked, the more part it can affect. So for this kind of changes, we just try to explain it and root cause it, but it's hard to solve because these changes are very dynamically. Today you change one line code, you got some regression, and tomorrow you change some code around it, it will get an improvement. And also if you change the GCC version, if you change some of the clock configs, it will just affect the whole clock linking, and it will also cause some magic change. So here we just try to explain it, and so and we don't expect we can resolve them. So here we list some examples, and the following will be a case study. So so here we saw a one line fixed patch for the memory management. It caused about 30% regression for the stress NG switch case. The changes actually is the patch actually just at one line here, and the effect is it's about 16 more bytes in the binary for that function. And we can see from the right. So we can see from here the function memory catch alloc block is 16 bytes larger, and it caused all the functions following it got changed. And there's also some relocation of the functions, I think by the compiler. So for this kind of changes, it's hard to analysis from as a white box. So we leverage some GCC compiler options. Try to test them. The test we did is that we force all the functions start rest be aligned on the 64 bytes, which is one catch line. So this is kind of the just a black box. So when we for this kind of things, the cases, we force the address line, then we retest that commit and its parent commit. If the performance change is gone, and then we can say, okay, here we see another function alignment cases. This debug patch has been merged just as a debug option. And the effect is that after enable this, we have seen much less reports from the 0 days recent report. So the function is the effect is just like the below. Originally, we have all the functions packed together tightly, and if we force align them, we can see this line. The function don't affect each other. When I submit the patch, Thomas Gaxina also a question, why not just turn it on? The reason we not turn it on because it has makes the kernel much larger. It's about 10% larger, and it will cause more TLB occupation, which may affect the overall performance. So we have to take it as a debug option. Following, I will talk about the data alignment. The key about the data alignment is about the catch force sharing. Also, the data part is more complex than the text because of how we have many different types here. We have the static layout, like the .data function from each .o files, and also we have specific functions for the percipient data. Besides that, we have the dynamic allocation from the kmalloc, vmalloc, and some very important data structure like the memory control group. They are just dynamically allocated, and sometimes the alignment inside them also matters and are very important. And for this kind of, if we saw a strange cases related with the data alignment, we really have we need to have more debug method. The first one is the perf C2C tool, which is once suggested by Jerry, and many thanks for that. With this tool, we can try to catch the hotspots of the catch force sharing of the code. And another important tool is the PA-HO. When we're dealing with these strange performance changes, the first thing we will do, we'll use a PA-HO to get the full map of the two kernels, and we do some comparison, trying to find if there's some alignment changes for the data structures. And if we located some hotspots of the catch force sharing, then we can add some debug patches. We'll add different patterns here and there, and just try to find something important. So this is a picture about the catch force sharing. So generally, I think yeah, I use these ones for our internal sharing inside team, but yeah, I would still list it here. So that means the data will be loaded from the memory to the catch on the catch line granularity. usually it's about 64 bytes, and that data could be loaded to caches of different CPUs. So when the access from different CPUs are all read, it's a good case because it got shared. But if there's any write here, it causes some force sharing. Like, because if one CPU changes that data cache line, when the other CPU want to read it, it has to be invalidated and reloaded, and cause quite some cache bouncing, which is a nightmare for the performance. So what we try to do is, if we are sure about there's some severe force sharing in some of the important data structure, we should try to separate them into different cache lines. Actually, during checking these strange performance changes, we found some of this, and we did add some separation patches to fix them. Yeah, for this kind of cases, we'll also have some debug mitigation. So just like the text alignment, we want one debug method is trying to align them. Here we also leverage one GCC option. Oh, actually, the link option. We can change the link script for the kernel, and we align all the .data sections and force them to be here for the x86. We force to about 16 kilobytes because we choose all the biggest one of the internal alignment. And when we see we will see a case and the suspect it is data alignment related, we will enable this, and then go check if the regression still exists. If it's gone, then we will say it's about the data alignment. Also, for the other types of data, we have some similar debug methods. For possible data, we will. One idea is yeah, there's a micro just to define declare the possible data. We can add some debug option. If we enable debug option, we just add some false alignment to those data. And the similar things for the kmalloc and the slab. We can force to change the kmalloc code. And for slab, there's already some alignment parameter which can just change the force some alignment for the slab. It will help us to debug these things. So here is it's about the hardware cache prefetcher. This picture is taken from the one Intel website, because in 0 day we only have the x86 test boxes, and we can only access to test them. So here it lists 4 types. The first one is the first 2 types are most important because we've seen several cases related with them. And for the current platforms, most of them they have them default on by default. Because generally they're helpful. We have seen many papers stating that, and in some our real test, we can see that the hardware catch prefetch didn't make a big difference and enhance the performance. But still, there are some color case it will hurt the performance. This prefetch is transparent to the software programmer. So yeah, before checking these strange changes, I don't know them. And only when we are debugging and we find these things. So the hard-to-catch prefetch will try to do some prediction and preload many things into the catches. Try to increase the catch hit rate. And because the algorithm is evolving, and so this prefetch's behavior will vary according to the platforms. So for some cases, we saw some regression on some platform, but for other platforms, it's just fine. So for the text alignment and data alignment, they're mostly about the software debugging, and we can try to add some debug with software method inside kernel. But if these things don't work, we will just turn to check the hardware catch prefetch. We can try to we can disable them together, all together, or one by one to do some check. Here is the adjusted catch line prefetch, which is an interesting one. So when this prefetch is enabled, if some data is loaded from memory to the catch, its adjacent one will be fetched too. But this adjacent doesn't has some limitation. It's not before or after, but just there. That adjacent catch line must be in the same 128 bytes chunk. So it's kind of just an extension of the 64 bytes we know. So which makes it the catch line actually be doubled. It's kind of aligned on the 128 limit. For this stuff, we cannot detect by the prof.c2c because it only takes about the real catch line, the 64 bytes. But still, yeah, still we if we got the prof.c2c report, we can still try to find some adjacent catch stuff here because in the prof.c2c report, it will give all the data addresses, and you can try to collect them if they are in the they are the adjacent ones. So here's a case study about the Hadoop prefetcher. So there's an optimization patch which remove a stretch page counter from the memory control group structure, and it caused about a 20% regression for the weird scale page default case. So the commit looks to be related with the test case because it's in the memory management domain, and which does involve a lot of functions related with the memory control group. So we initially did some debugging by add some padding, but there's some strange things that if we add some one line padding, which means if we add 64 bytes padding, the regression is gone. But when we add change the padding from the 64 to 128, the regression is back again. So and finally it turns out it's about the hardware prefetcher, the adjacent cache prefetcher. So we found that actually in that structure we have 3 hot members, A, B, C here. In original before the patch, they are in the different cache line, but they are not in the same 128 trunk. So they don't affect each other. But with the optimization, the hot members are poured into the same 128 trunk, so that now they have some cache force sharing, which is a kind of the extended cache force sharing. And this one causes the regression. So the final solution for that is we separate these 3 hot members into different 128 trunks, and the regression can be recovered. Okay, so it goes too fast. Actually, for the hardware prefetcher, we actually I've said there's another case that for about the just the air to catch prefetcher. So recently we saw a strange case just about last month, which is also about the memory control group. So we have some improvement about the counting. So the R state is introduced to the memory control group, and we saw a big regression, about 40% regression. We tried those software debug method, but seems it doesn't work. And only if we turn off the air to catch prefetcher here, or let me go back to the first one, then the regression will be gone. So it seems there's some strange access pattern to the global hotdesk structure, and it causes hardware prefetcher to do some very aggressive prefetcher, but those prefetcher is not accurate, so it wastes a lot of bandwidth about the bus, and it causes other regression. So here the point here is that if we see some real strange cases, we can try to disable this prefetcher and redo the test. Sorry. And here is another. We have another idea. Try to mitigation this stuff. Because these strange regressions are really annoying. No matter the same for the patch author and for us, because we have to put a lot of effort and time try to debug them and try to explain them. So we want to make the kernel performance more stable. We want less surprise. So here is kind of the selective isolation. Because in the current kernel, we have all the modulars compiled together, just like here. And the idea is we try to select some .o files, and we for each .o file we just need to add alignment to one of its function and one of its global data, so that it can be seen like a isolation buffer. Just like in this diagram, the ADI will be selected and add the alignment, and then it will separate the kernel into different capsules. So any change inside that capsule will be just inside that capsule and won't affect others. So it's like just like a capsule in a big ship. If one capsule get broken, it doesn't affect others, and the ship is still safe. And the rule we want to have is that we don't just evenly choose the modulus from the kernel. We will try to select more in the critical and the early modulars, because those patches are more likely to cause these strange performance changes. For example, the MC part, the machine check part, the Tony and the Boris has been bugged many times because zero-day report many strange changes for their patches, but they feel innocent because the MC is not commonly used modulus, and mostly in most times there has nothing to do with the benchmark. So the reason I think is we think is that just because it's in the early part of the kernel, it's in the architecture code. So any change of it from it will impact the most of the kernels. Yeah, I think yeah, that's the reason. Just because it's linked early. So we will just try to select more things from the early modulars and the critical modulars. So we actually did some experiment that we choose because as I said before, we have tracked about more than 20 cases. We choose some cases for the text alignment and the data alignment. We do some experiment. We choose some file, just follow the patch. Follow that patch, and we add alignment, and then we redo the test, and actually those regression is gone. But yeah, we just do a few. So we have some confidence in this way, and also as one of the advantages that because we just select a few modulars, so the size impact is small and control. Okay. Here's some how to do's. So we for checking the strange performance changes, we have some debug methods. And also have some mitigation ideas. Some are already merged, some has been posted. So we will try to go on to upstream them. A lot of things that about the POV-C2C tool. POV-C2C tool really helps in our work, and we can get a lot of useful data. So if that tool could be extended to cover the 128 bytes, which is double catch lines, it will be great. And will help us a lot. And also the last thing what we want to do is about to check more about the hardware prefetcher, because the hardware prefetcher is just a 1 and 0, so there's some still magical things we cannot figure out. Just like the case we talked, we don't know what strange access pattern caused the regression. And we can even think of something we can just mitigate the hardware to make the hardware prefetcher more intelligent. The last thing is that yes, there are still some cases remain unexplained. So we would like to check more on them. And in this talk, we talk about the cache alignment. But in those cases, we suspect they're related with the TLB. But we just don't have proof to them. So this is one of a lot to do. Okay, that's all for me. Any questions?
I have one. You mentioned that there was 3 hot items, and you separated A, B from C. Would it be better to separate A, B, and C across 128 byte chunks, or was the structure just not big enough?
The structure is very big. The structure is very big. The memory control group structure is about 4 kilobytes. So my patch is just separate them far enough. We just keep the inline the in cache line alignment not changed. We just move the whole cache line stuff away because in the memory management they already consider the cache line. So for this A, B, or C, there's already some the previous death structure already has some cache alignment to force the one cache line. But unfortunately, it hits the adjacent cache line prefetcher.
Okay, so you found out that they were actually not on the same cache line. You put them back on the same cache line. Is that right?
No. We the ABs they are in the cache line, the same cache line. The C is in another cache line. The solution is keep all these cache line unchanged. We just move them far away. We like the C is in the 2n plus 1. We moved down to the two line plus 10.
Okay. And this is because these are actually 2 cache lines, right? Like you're talking 128 bytes, and the line there is 64 byte alignment, that sort of thing, is what I understood from earlier. Okay. All right. And how far did you have them move them? Did you have them move them that far, or would it have been just fine enough to get to 2n plus 2?
2n plus 2. So Yeah. Yeah. Yes. If we, as I said, the one debug method is that this is after the optimization patch. If we add some, the one cache line padding here, it just push it back, and the regression is gone. So, but that will involve some additional stuff padding, right? We don't want to add some more cost, so we just do the reroute stuff.
Okay. All right, thank you.
There are some questions in the chat. Do you want me to read them out, or can you read them out?
Yeah. Okay. Okay. I will. I'm opening the chat box. It's loading.
Yeah, it does take a little while. Well, while it's loading for you, let me start out with Case is basically saying, was talking about this might help isolate performance impact of FG ASLR as well, randomized within capsules instead of across the entire memory space.
So I cannot recommend you to disable it because we have done some other tests. In generally, if we disable the prefetcher, there we will see some the decrease of the performance. So this disabling is kind of by case. So if you disable it, you may see some gain in one case, but you will see some penalty from other cases. That's my understanding. Okay.
Go ahead. You go ahead and read them and then answer and talk.
Yeah. Now, there's another question from the chat window is that have you ever observed unexpected performance improvement caused by the alignment changes? And yes, actually, they're quite many. But usually people don't care because okay, I got improvement here, so it's fine. But if there's some regression related, it will be a more severe problem. Yeah. So in short answer, yes, we're seeing both the regression and the improvements related with the cache line alignment changes. Okay.
One question I have is more on the, so MEMC group is one example. Do we have like a data for like maybe all the structures the kernel have like similar, which can be like there, what are the hot members there? If the alignment changes, the potential for regression and stuff?
Let me think. So the memory control group is, I think, is the most common stuff, most common stuff we've seen. For others, let me check. For others, it's just some sparkle stuff. We've seen some namespace global data. We've seen quite a few of about the percipio data. But for memory management, yeah, it's mostly related with the memory kernel group.
Does anyone else have any more questions?
Could that just be because MEMC group has the most changes going on right now? I mean, the MM struct generally doesn't change. The VMA stuff kind of is sitting the same it's been for, I don't know, 2012, I guess, maybe. Could those also be affected in this manner?
I think because in the most test platforms of the 0 day, there's some servers. They have more than 100 CPUs. So for this alignment stuff, will affect those servers mostly because the catch effect will be amplified on those. Like for because that test strategy is global and every CPU need to access them. Mostly in the update in updating statistics. And yes, just as you said, recently there are quite some changes, improvement for the memory control group. Yes, and another funny is that the statistics is always hotspots for the micro benchmarks and for the big servers with many CPUs. Because there's some contention, they are trying. They eventually need to update the one global states. Any more questions?
So I don't have a question, but more for like I really want to like thank you. This is like really helpful in catching and particularly testing and regression, and these reports are really helpful in finding the issues. So yeah, thanks.
You're welcome, and thank you for the patience. Yeah, we've bugged quite sometimes recently. Yeah.
Okay, Brett Olson's also raised his hand. I don't know if you want to unmute and be visible, Brett, or.
Oh, can you please help me because yeah, I don't know how to just unmute him.
Yeah, no, he has to unmute himself. You can't unmute him. It's all very much self-person controlled. So let's just check and see if he's got something in the chat. Ben, do you have any comments you want to type in somewhere?
Oh, thank you, Ben.
Okay.
If no more questions, I think we are fine.
Okay.
For today.
Well, we can keep the discussion going over in the chat. And thank you very much for an excellent presentation, Feng. Much appreciated. And I know I'll be probably watching the video a few times on this one to figure some of these things out myself. So thank you again for doing this.
Thank you, Kat. Thank you. Thank everyone for attending.
Okay. Take care. Bye-bye.
Bye.
And with that, I think this concludes the referee track for today at Linux Plumbers. And so we'll see people back here again first thing tomorrow morning. Have a good evening.